Hello and welcome to another Developer Essentials. So this time around we are going to be taking a look in depth at materials. So we've already worked with materials quite a bit already in terms of assigning them to things. We've done that quite a bit. What we haven't done is start to look at specifically how do materials actually work and a few sort of key important differences in terms of how they actually behave. So what I'm going to do is I am initially going to set up a material that is just going to be for the ground. And as always, I'm going to set up a plane for the ground. And we'll start with just assigning the material. So really simple setup. We're just assigning that material and we're done. I'm also going to set up a couple of cubes that are going to have their own material as well. So they've got a material. Let's change that. So let's go for kind of a sea green color, I reckon that would be. So we're going to have this cube. Let's chuck another one here, and let's also chuck another one here. Actually, let's move it over to there. So a few different cubes that we've got. That works. So let's see a couple of key things already with materials. So the materials are shared. So if I change this material, it changes all of those cubes. So multiple objects can access the same material. Changing it on one changes it on all of them. We've seen with a lot of stuff that when we change it in the inspector, those changes get reset. But materials are an asset. So what that means is if I decide, oh, I'm testing this, I'm going to make these more of a orangey red color. And then I'm going to stop it so I can go back to the color I had, and yeah, it doesn't get remembered. Well, sorry, it doesn't reset because I'm modifying an asset. I am not modifying the just the version of it at runtime. So materials, we need to be careful about modifying them. The same is true if I go for modifying these in code. So this is something I need to watch for. Scripts, and I'm going to set up a script that is just going to be material demo 1. So I'm going to put this script only on one of the cubes. So only one cube will actually have this script. So I've got one cube that's got it, the other cubes do not. So one cube only has this script. So what I intend to do is I want to show you how I can access the material in the code. So I want the material that's on this object, and I can see the object has a mesh renderer, which has the material. So I can go from that. So what I can do is I can say get component, mesh renderer, and I'm going to actually cache that. So I'm not making this variable public because I don't need to change it in the inspector. I also am not going to make it serialize field because, again, I don't need it to be in the inspector. This is just internal to this class, so I'm listing nothing before the type of it, which means that it's going to be private. It's going to be internal to the class. Linked MR. So I can say linked MR, so for that. Retrieve the linked mesh renderer. Now, one of the things you might be thinking is, well, I can attach this script onto anything, and then if I attached it onto something, it would make it not work, because I could attach it on something that doesn't have a mesh renderer. We can actually enforce some rules here with our scripts, and in particular, we can have our script say, this thing requires this other type of component to be there. And we can require multiple different ones. What I can say is require component type of mesh renderer. What that will mean is this script can only be attached on something that has a mesh renderer. And if I try to attach it to something that doesn't, it'll add a mesh renderer to it. If I tried to remove the mesh renderer from an object this script is on, it will tell me no. And we can actually see that. If I go and try and remove this mesh renderer now, I can't, because the material demo script depends on it. So required component is a really good way of ensuring that we're essentially saying, yep, this script requires this other thing to be here to function, and Unity then is going to enforce that behavior. So this is a really good approach. So we can retrieve the linked mesh renderer. Then I'm going to change the material, and what we're going to see, whoops, linked NR. If I type material, you can see we've got a lot of different things. We've got material, which is the first thing in the list, because an object could have multiple materials. We can see this is actually a list, so there can be multiple materials. So dot material is referring to the first instantiated material. Materials gives the entire set of ones as an array. I can also then use get materials to populate that into a list. Then I've also got these shared ones. So what is it meaning by this difference between instantiated and shared? So let's find out. And with programming, this is something I could absolutely look up, but we can also experiment and see what happens. So I'm going to start with material, and I can change the color. So I'm going to, I can't remember if there's a random, beautiful. I can pick it'll just generate a random color. Now we're talking. Randomize the color. So let's see what happens. So this script is only attached onto one object. Every time it runs, it should randomize that color. To make it a bit easier to tell what this is supposed to be, I'm going to reset this color to something that we know really reliably and we can easily go back to. So we're setting it to a hue of 150 and then saturation and value or brightness to 75. So let's run it, see what happens. Runs, and that cube changes, which is good. These other ones don't, which is also good. So that's if I randomized that color. Well, we know there was a thing called shared material. See what happens if I do this now. So I run this, and all of them change, and we'll notice the actual material here changed. So when we use shared material, we're actually modifying that global one. So shared material will change it for everything that is using it, whereas material will change an instance that's specific to this object, which that instance only gets created typically when we actually go and run code that modifies the material. So if I change this to material, so just changes us, randomize color, change the shared version, will affect others and the asset. So linked MR shared material color is random color HSV. Now I'm going to leave this one commented out because I usually don't want to mess with the shared version. There might be cases. So if you wanted to make changes to all things using that material, then you could absolutely use the shared one. The instance one is usually what folks are often after in most cases though. So I'm going to add this script onto all of these. So all of them should now get a randomized color assigned to them using the color to HSV. So cool, got 3 colors. The actual base material hasn't been changed, which is good. So we're not modifying our asset. We generally want to avoid cases where the code would directly change an asset. We usually want to just modify the specific one. So that's cool. We can mess with the color. We also have seen with this that we can change the opacity of these, but to do that, so I can't at this stage adjust the opacity or the alpha and it actually do anything. If I want it to do anything, I need to switch this to lack of transparent. And then now these can fade in and out. So that's pretty cool. What if I wanted to control that fading at runtime? So this is going to run, it's set a color there for it, but what if I want to actually have that fade at runtime? So that's something where what I could do is I could set up here, okay, serialize field, float, fade period, make it 5 seconds. And then to calculate the current desired alpha, so desired alpha, I'm going to make use of mathf ping pong, time.time, provided our fade period, and by dividing by fade period, this will give us a 0 to 1 value. So we're calculating our alpha. We are using ping pong, so it cycles. Now ping pong is going to start at 0, build up to 1, and then go down from that. I kind of want to invert that, where it starts as being fully there and then fades out. So I can do, to do that, I can do 1f minus this. So no ping pong, when I'm dividing by the period, is always going to go between 0 and 1. So now when it would have given me 0, it'll give me 1, and when it would have given me 1, it'll now give me 0. So that's cool, I got the desired alpha. Let's look at what I can potentially do for changing that. So my material, the color, actually we can check and see, well, we don't have a direct thing for alpha, but I can check for, I can get the color, and maybe I can get away with just directly setting that, and I can't. Which I expected that. That's similar to, you can't just directly go transform.position.x. So okay, I need to modify the particular color. So what I could do is current color is the materials color. Then I could say current colors alpha is equal to the desired alpha. That will work. So these are 0 to 1. And then I can set that color. So let's see what that does. Let's see if that gets the behavior we are after. So we'll let this run. So it fades out. And then it'll fade back in. So that's pretty cool, that's working. I'm going to make it that these use slightly different fade periods. The reason being that I want to make sure that one material isn't impacting another, just to be certain. I'm pretty confident it's not because the colors are different, but that's working pretty well. So okay, we can modify the, update the alpha transparency for the material, so we can be making something fade in and out. and we can be making changes to that as it's running, which is pretty cool. We have seen that we have this thing called emission, which will make something brighter and emit light, and we can test with the materials. If I pick like of the ground, I can turn on emission, and then I can make this super bright, and so it's actually emitting light. So I can do that. What if I wanted that emission to also be able to be turned on for one of these? So if I wanted to be able to set here, serialized field has emission, I'm going to say that's false. I'm also going to have a color control here, emission color. And that's going to be color, let's just make it initially that emission color is black. Now the other thing that I'm going to put in here, because we can group stuff and we can display a helpful little header in the inspector there. Emission control, emission settings. So that's pretty cool. So if emission is enabled, we want to change the emission color. So we can have just one of these maybe do that. So I could be saying, okay, well, if it has emission, then if I take a look at the material, link to my material, I don't have a thing for emission. So it's not there, but I know that it's something the material supports. So there's a couple of properties like the color, the main texture, things like of that are that common, that ubiquitous, that there's direct variable there we can modify. For other ones on the material, we generally find we need to use things like set color. Can you also have for some things set float, set texture, vector, lots of different ones there. So this would be one where I use set color. And the first thing is it needs a name. It's giving me the example of underscore color, which would be for the main one, but I need to know the one for emission. So here's how I can find that out. I can, with my material selected, I can, the three dots at the very top, I can switch to debug. And then we've got all these different things here now that are visible that are collapsed. And in particular, what we're looking for is saved properties. And we can see emission color. So handy way to track these down, we switch to debug mode, and then we can find the names of particular things. So now I know that it is emission color, and I can set that to be like that. We'll configure the emission color F enabled. So that's pretty cool. We'll pick one of these and we're going to make it that the emissive color is going to be a super bright yellow. Now, I mean, one thing we immediately notice is our color picker doesn't look the same as it did when we were configuring the emission color elsewhere. So, okay, that's a potential warning sign. Should still probably work. We've still managed to set a color. Let's run it. And, okay, doesn't look like there's any emission on this because we can see the instance here. The emission's still turned off. So emission is a thing that has to actually be turned on. There's a keyword associated with it. So materials can have, well, they're linked to a shader, which the shaders have keywords. Now, we typically can't always see the keywords available here. So we can't nicely go and find them by looking and saying, okay, cool, well, this is what the keyword is. So we don't have those available for it. So we have to find another approach for enabling this, because we know we can enable stuff. And we know the syntax is going to be something along the lines of material enable keyword. We need to know what that text is, because it's not going to just be emission color typically. We need to know the particular keyword that we are looking for. Now, to be able to do that, we need to actually track down the materials. And this is where one of the ways of doing this is we can just be searching for the different variants that might exist. And we can search for those particular keywords. Trying to find those keywords in Unity's documents is often tricky. It really can be very tricky for doing that. So that is where what you generally end up doing is, yes, we have to actually go and just search for particular stuff. And, we can see, well, this one's enabling the particular option. So we can see that, yep, we've got this keyword that they were trying. And so we can use that. So again, it would be nice if there was just a spot in Unity's documents where that keyword existed and you could easily just go and find it. And just hoping that they have actually now added it in. I'm just going to, in hope, do a search that they have actually enabled that, and as best as I can tell, that keyword does not exist in the logical places where you would find it, but I have managed to track down some material parameters. Now you can see the different features. So this link to these particular keywords that we can enable, I will put this link into the description. And I'm going to make sure I've got that in the list of stuff that will go into there, because that is a really tricky thing to track down. I could only find it by I knew what I was looking for with it, which is not really the way that you want it to work. But so we've now got the keyword there that we can enable for it, and that's what we'll find with some features where we have to actually enable a keyword for it. So that's something to remember. So if I run this now, let's see what we get behavior-wise. So we run it, and we can see that emission is working. And if we come and look, the material, it does have the emission there, but it is kind of getting messed up by the alpha that is happening on it, which is not really surprising. Mixing emission with a transparent material is absolutely a weird combo. And that is definitely messing with it. It's also the fact that emission tick box is getting reset, which is not a thing that would normally happen. That seems to be an artifact of me. It's happening in response to me editing the material there, which is quite odd behavior, and I suspect it's due to me enabling that emission in code. But we still don't get the different color picker, because this is still just our regular one. We have to actually tell it that we want it to be the special HDR color picker. So to do that, we use another attribute. So we use the color usage one, and then we can control different settings. So we've got, does it have alpha there? Does it have HDR? So in this case for emission, alpha doesn't make sense, but we do want it to be HDR. So if we set that up, then we can go and mess with this. We can see we've got our HDR color picker. No alpha, but we do have the other correct settings there for it. So okay, that gives us a way that we can be working with this, and we're modifying the individual materials. Now, this is not actually the best way of doing this, of changing the materials in this manner, because what this is doing is it is actually creating a new copy of the material, which is a lot of extra overhead, and we don't need to do that. We have an alternative of what we can do. And so what I'm going to do is I'm going to create another material that's for a sphere, and we're going to have, magenta is kind of a weird color to use for this, given that magenta is usually associated with something not working. But hopefully I am not tempting fate too much by using magenta for this. Because what I want to do is I want to have these spheres. I want them to be able to change. So I want to achieve the similar effects to what I'm doing with demo 1, but without needing to have it create a new material instance. Because when it's doing that, it is creating a new copy of the material. And that means that there's overhead there with that. That's something, if we were doing that on a lot of things in the scene, that's starting to get potentially really quite expensive. It's not a good approach. And we have a better approach that is faster and is going to work significantly better. It scales up really well. It is a bit more code, but it is absolutely workable. So I'm going to steal a whole bunch of the stuff from the other one because we want to keep all the same settings. We want to still also require the component. So I could rewrite these again, but it's exactly the same stuff. And I'm not going to, there's no real sort of value in rebuilding the stuff. So cool, I've got this. So I specifically don't want it to create a new instance of the material. Because if we run this with the spheres, I want them to be changing, same as the other ones did. Except the key thing is I don't want there to be any new materials being created. Because we can see the spheres, every sphere is just saying it's a material, whereas these are the instance of the material. It's created a new one. So I want to get the same effect, but without creating a new material. So rather than having, in this case, 3 new materials, 0 new ones. And I am able to do that. So I can do that using something called a material property block. So we have these objects called material property blocks. Prop block. And what I do is I say, hey, mesh renderer, get the property block. And I give it the particular one to be storing stuff into. So that will retrieve the property block, and I just need to make sure I knew that. So retrieve the property block, set a random color. So whereas before what I would do is I would take the mesh renderer and I would set the color property of the material there. Now I go through the property block for everything. So I can say set color. Now I need to use by name for everything. So conveniently I know that it's going to be color. And then I can do random color HSV. Done. And then I just say, hey, link mesh renderer, set the property block. So get populates it with info, and then set applies the particular overrides. So now, if I try and run this, let's see what happens. What I'm expecting to have happen is we get these, all three, as different colors. So they're different colors. And if I check my spheres, you'll notice they're not an instanced material. I haven't created a new material to get this effect. So that's pretty cool. We've created those. Let's mess around and see what bits we actually need to do. Do we need to every time do this get? Can I mess with the order of these? So this is something where I kind of know what I'm able to do with this, but I want to experiment around with it. I'm doing this experimentation because that's something I want to encourage you to be doing. When you're working with the code, experiment with it. Try different things. Don't be afraid of it breaking stuff. So let's run this, see if these still actually change. So they don't. Okay, so that tells me order-wise, I need to make sure I do the set afterwards. So it's not a case of we're linking this to a property block and then we can make changes to that property block and it just applies. We have to actually make the changes and then we set it. We apply it at that point. So okay, let's try it now. See if it is working. So that's working. So that's pretty cool. So the get property block, we really don't always need that. We can use that if we are needing to read data, so we can actually read out things like the color. If we're not needing to read out the color, then we can just use get property block, we can just create it and apply it. So that's cool. Let's look at what the property block version of working with the transparency looks like though. So with that, I'm going to move my property block up here so that we can be accessing it in a few different places. And again, my desired alpha, I can just steal largely this code, because what I would be able to do is I know I need to go through the property block. So I need to get the current color. So, okay, property block, get color, and I know it's color. And I need to apply the changes. So, okay, let's see how that works. So I've retrieved that color. I also then need to set it. So property block, set color, and a name for it. Okay, so let's see if that works. Because what I'm going on principle-wise is because I've already set the value, I can then safely get that value. Let's find out if that actually works. And we'll try running this and we'll see. Now we are getting an error, and that's because it's not always safe to create things here like this. So the property block, we have to actually do this instantiation of it down here. And there are a few variables that we will encounter that have to be instantiated inside a function. They can't be instantiated up at this stage. It's too early in the process for them. So we have to create it down here and start. That will clear this set of errors that we were getting before. That's still the previous set of ones. Because it only clears when it plays the game. So now we run it. Okay, so they're still not changing transparency, and that's because the standard easiest thing to miss when you are going and trying to change the transparency of something and it's not happening, always go and check your render mode. Odds are you've left the render mode at opaque. So let's test that, and we can see that's working. It's fading out properly. Fading back in, so that's looking pretty good. And we can double check that, yep, again, we have not gone and created another instance. It's still completely separate, which is great. It's tending to pick some really, oh, there we go. Now we've got some brighter colors. That's better. Obviously had a streak of random numbers that were very dark colors. So for a minute there, I did think there was maybe a bug. But we've got transparency working. Well, the only thing we haven't got switched over is emission. So let's see how that looks for switching that over. So we would do that here. And again, so property block. So in this case, with property block, if we take a look, we don't actually have an option for enabling a keyword there. So property block, we would be able to set the emission color, but we don't have this method for enabling a particular keyword. So there isn't actually any way with a property block for us to enable a keyword. So we have to actually still go via changing the material. So it's less than ideal, but it is unfortunately the only option that we have there with that. So let's see how it behaves though, and in particular, whether that will cause it to create another instance. So we're going to pick the middle sphere, turn on emission, and make it a kind of greenish white color, and let's see what happens. So it does correctly turn on emission, but we can see it instanced that object immediately. So this is a downside with the property blocks. They work really well for things like adjusting the colors of things, so adjusting colors, adjusting textures, sending through vectors, all sorts of extra information. We can send them through with property blocks and avoid creating a new material. But as soon as we need to change stuff like a keyword, that is going to create a new instance. So property blocks don't support enabling a specific keyword. This will create a new instance. So not ideal. But we have still managed to, with all of the other settings that we're working with, we've managed to avoid creating another instance there. So generally, if you are working with materials, what I would recommend is, where possible, generally steer with using things like property blocks. It avoids creating extra instances, which is going to introduce extra overhead. And that's the main thing. Extra instances will have a higher cost in terms of the processing, working with things there. Ideally, we want to stick with using property blocks. And our code looks fairly similar. It is a little bit longer when we're working with property blocks, but a lot of the syntax is very similar that we're working with there. Main things we need to remember is, as soon as we're doing changes to the material, it will automatically create another instance. If we instead changed shared material, it will go and modify every instance and the asset itself, which is often less than desirable. You can easily get bugs then where, okay, well, we've modified this asset and we have to reset it back to what it was before. Not desirable. We can switch to a high def or HDR color picker by using this color usage attribute, where we can add in or disable selecting of alpha, and where we can control whether it's in the HDR mode or not. We can provide a nicer grouping of settings using this header attribute, and we can make it mandatory that this class has to be attached to something with a particular type of component by using require component. So a few different cool ways of working with stuff there. We've seen we can get a random color if we want as well. Again, super handy process there for if we just need any arbitrary random color. So that's the key things there with materials. One thing we haven't seen is, well, what if we just want to have something where it swaps to another material? So let's chuck in a capsule. And what I'm going to do is this capsule is just going to randomly pick a material, demo 3. So this capsule, let's position it in the world. And all it will do is it will randomly pick a material that we assign to it. Let's bring this over here. It's going to have material demo 3. And I want to give it a list of materials. And this I'm just going to call materials. I'm going to use similar stuff where I want it to have a mesh component and where I want to be storing the mesh renderer and where I'm going to retrieve the mesh renderer. So what I then want to do is I want to change its material. So linked mesh renderer. Now we need to think, okay, am I changing the shared material? Am I changing the material? So that's something where, well, we don't just have a set material. We have to actually be linking it to something. So let's try the different ones. As I said, experimentation with things like this is a good approach. So I could set the shared material. It's going to be materials, random range, 0 to materials dot count. Assign a random material from the list. So that's pretty good. And what I'm going to do is that list is just going to have every single material that we currently got. It could end up ground, could end up the cube, could end up the sphere. So, okay, I'm changing currently just the material, sorry, the shared material. So let's see what the behavior we get is with this. So it runs. It's picked a material, it's not instanced it, so that's a positive sign. Let's see if we see any difference with changing just the material. Going to run, and again, so we're going to get similar behavior. I would, normally with something like this, where I am setting sort of that common material for stuff, I would probably normally just change the shared material. It's not going to, in this case, as we saw, we're not seeing a difference in behavior, but just because of how I'm using this, where my intent is that I'm setting this and I might have this run on multiple things and I don't want there to be separate instances, I'm wanting them to refer back to that asset. So I would normally use shared material in that case. And what we would see if we run it, because we know that it does look like it is a shared material, and we could confirm that by, if I grab, that looks like it's the cube material. So if I change this, it does actually change the particular one. So it's behaving the way that we would expect. So we can change materials in code. We could change that at any point as well. So it means you could switch something from running, having one material to another. You could switch something to having a material that's emissive, for example, or that's transparent. So you can create nice visual effects there by changing a particular material. So you can change the visual appearance of something by directly modifying the existing material, changing things like its color, its emission. We've got a lot of other different settings here. We could also be changing the material there based upon actually swapping to another material. And as well as just changing the properties for a material, as we can see, we've got a lot of different shaders here. These shaders will give different visual effects. So, for example, at the moment we've got shaders there which can receive light and can cast shadows and receive shadows. But if I switch to, say, an unlit color one, all of the shadow information disappears from these. So we could switch to something that is unlit and has color. We obviously have ones here for different vegetation and terrain. Generally, you're not going to want to select those. There are specific shaders for the user interface, for various visual effects. So there's a lot of different shaders that we can actually be working with on this. And we can create our own shaders as well. And there's a whole bunch of different ones there that are legacy, so older ones. So changing shaders, setting up our own ones allows us to really customize visual effects as well. So key things to remember. If you change a property within a material, like its color, you create and you're doing that on material. So the mesh render is material. You will create a new instance of that material on every object that happens on. So it only modifies that particular object. That is something that means we can end up with a lot of materials created, which introduces overhead. If we changed the shared material, we modify the asset. That means everything using that material gets that change. So we need to be cautious of doing that. We can enable keywords to turn on things like emission and other functionality. We can also, for some colors that are not, and properties that are not directly available, we can use these set functions for setting colors, textures, various numbers and other parameters. So this approach is going to always create more materials. If we want to still change just one or an isolated number of objects, we can use material property blocks that we have to create. We can't create them outside of a function. They have to be created inside a function, but we only need to create them once. Then we can set values into them using similar syntax to when we're working with materials, and then we can apply those. If you've got an object that has multiple materials, you can get and set the property blocks for each material independently. So it's not tied to, it has to be the same properties for every material. If an object has multiple materials, each one can get its own property block. Property blocks can set things like colors and textures, but they can't turn on keywords. So we still, if we're enabling keywords, that will still create another instance there. If we're doing that at runtime, obviously. And then finally, we can swap materials on things. So we can change to another material. We can do that at any point in time. And that's a pretty cheap operation to do. So we've got a sense then with this of different ways we can work with materials. So this is stuff you could combine with other things that we've looked at there. For when something is moving, you could make its color change based upon how fast it's moving or how far it is. You could be changing colors of stuff to indicate that it is interactable. Keep in mind color blindness though with that. So if you're using color to convey gameplay information, make sure you have methods beyond just color. There are also a lot of freely available tools where you can test your images, your game, to be able to see how it would look for people with the different variants of color blindness. So that's an important thing to do, but a general big rule of thumb is never have color be the only way to convey important information in a game. Because you potentially make it unplayable to a substantial number of people, and that's not a good approach. You want it to be accessible and interactable for a range of people. So use more than just color. Use color, use symbols, use sound, use text, use multiple modes of conveying information. But use color to enhance stuff, but don't have it as the sole point for communication. So that's a bit of an overview with materials. We will have more of a look at things like shaders and stuff like that we can do with those. But this is a bit to get started with so you can start messing with the materials. Again, don't be afraid of breaking stuff. Dive in, try and make things so that, you know, it's changing color based upon where it is in the world, all manner of different things. Just try and experiment with different stuff. See what you can actually create with these and see what kind of cool effects you can make happen with it. Thanks folks, that is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.